All right, I'm going to go over the first midterm here for those of you who maybe got something wrong and want to retake it and don't understand what you missed. So let's see, the first one, we have this shape. You want to make the area as big as possible, but you want to have one horizontal divider and two vertical dividers. Therefore, our perimeter, so we add up all these lengths, right, all the fences, we have three x's, 1, 2, 3. So 3 x's, and then we have 1, 2, 3, 4 y's, right? And all those lengths of fencing have to add up to 600 feet. So we'll say 600. Okay, that's how much fencing we have. Then our area is just x times y. We want to make this as big as possible. We want to make x times y as big as possible, given that this is true. So we either solve for x up here or solve for y, it doesn't matter. Plug it into here, and then do our algebra. Let's solve for y. Why not? Because it's fun to say why not if you're solving for y. Okay, let's solve for y here. Okay, so 4y by itself is equal to 600 minus 3x. I put the 3x over here, divide everything by 4. Y is, it's really nice, 600 divides by 4 evenly, 150 minus, this one's not so nice, 3/4 x. Now we're going to plug that in here. So now our area is just x times this, right? Our area is x times y. Y is this. So x times 150 is 150x. X times that is minus 3/4 x squared. So that's our area. We want to know, notice this is a parabola. The a is negative, the x squared term is negative, so it's going to open downwards. We want to know what x makes it the biggest. What value of x makes that the biggest? So it's the negative b over 2a thing, right? The vertex. So negative b over 2a, b is 150, so it's negative 150 divided by 2 times a, that'd be 6/4, negative 6/4, negative 6/4. And we can get that, so let's see, that's 600, I think that's equal to 100. You can try that out, because multiply top by 4 is 600, 600 divided by 6, the negatives cancel. That's 100. Therefore, y, that's x, okay, that's the x value. So x is 100. Y then is 150 minus 3/4 of that. So y is 150 minus 3/4 of 100. From this formula here, 3/4 of 100 is just 75. 150 minus 75 is 75. So x is 100, y is 75. So the area then is 100 times 75, which is 7,500 square feet. Okay, the trick to these is you write down a formula for the perimeter, you add up all the lines and everything, you write down what you want, a formula for the area. Typically, the problem is you have 2 letters here. We only want 1. So you use this formula to get rid of one of them. Solve for either x or y. Plug it into here like we did. So then we get a formula that only has 1 letter. And generally, it'll be a parabola, so it'll have a maximum or minimum depending what you're standing for. All right, that was the first one. Most people did really well on that one, but it was definitely tricky. So if you didn't do well on that one, hopefully now you get it and can do well on a similar one. Okay, the next one here. Okay, this was just plugging stuff in. So you plug in this in f of x plus h. So let's see, 1 over, wherever there's an x, you plug in x plus h, so 2x plus h plus 1 minus, just the function is 1 over 2x plus 1. And all that's over h, and we have to use common denominators here because we want to simplify this, and the only thing we can do this is common denominators. So this one, so basically you multiply these two together for the common denominator. Okay, so if you multiply the bottom by this bottom by that one, you got to multiply top by that one. So in the top we have 2x plus 1 divided by, and I'm going to multiply that out, 2x plus 2h plus 1, 2x plus 2h plus 1 times 2x plus 1, right, because these cancel and we get the same thing, minus this one we got to multiply by this, so the top we go multiply that. So we have 2x plus 2h plus 1 divided by 2x plus 2h plus 1 times 2x plus 1. So again, these cancel, so we're left with 1 over 2x plus 1, so we did it right, all over h. Now we just subtract the tops because they have the same denominator, so we can go this minus that. And notice, this is really, everything over here is negative. Everything is negative. So the 2x takes away the 2x, the 1 minus 1 goes away. All we have left is a negative 2h. A lot of people lost that negative there. We have a negative 2h left at the top. That's it. So we have a negative 2h divided by all this stuff, 2x plus 2h plus 1 times 2x plus 1. And all that's over h. These h's cancel now. That's the whole idea. Once those cancel, we can plug in h equals 0. If we plug in h equals 0 there now, we have a negative 2 on the top. On the bottom, we have 2x plus 1 times 2x plus 1. Right, because h is 0, this is 2x plus 1, 2x plus 1. Now, that's obviously 2x plus 1 squared. You could have left it like that. But the simplest way to write that is negative 2 over 2x plus 1 squared. A lot of people lost that negative. You got to be really careful, minus all of them. So the answer is negative 2 over 2x plus 1 squared. Okay, that's the second one. Let's move on here. The third one was the semicircle thing going on. Right, a function gives a vertical distance. Okay, there's one just like this in one of the practice tests. You have to know how to write the equation for a semicircle. It is centered right there, which is x equals 4, 2. The radius is clearly 3. And this line goes through this point and this point. It's pretty clear, plus I set it up there. So this point is 0, 5, and this point is 7, x is 7, and y is 8. And why did I put an 18 there? I think that's right, x is 7. Yep, 7, 8. So first we get the line and subtract the semicircle. All we got to do is write the equation for the line, the equation for the semicircle. So you guys have been doing lines since first grade. A lot of people got the line wrong, unfortunately. So clearly, okay, the slope, it goes over 8 and up 3. So the slope is 3/8. Sorry, the slope, it goes over 7. Goes over 5, 6, 7, and up 3. So the slope is 3/7, right? It's not very steep, less than 1. So yep, it's a fraction. It's positive. So okay, it's positive. Always check those things. Is it less than 1? Because fractions get confusing. It's not very steep. It's less than 1. It's a fraction. And then the y-intercept is clearly 5. So right away we can write y equals 3/7 x plus 5. Because an x is 0, y is 5. Yep. Okay, now the semicircle. First you write a circle, the equation for the circle, and then you just take the top half. So it's centered at 4, 2. So we had the formula x minus h squared. We worked a lot with this. Had quizzes on this. Equals the radius squared. H is 4. So x minus 4 squared plus y minus the y center is 2 squared is equal to radius is 3. So that's 9. We want to solve for y. Put this over here. So y minus 2 squared is equal to 9 minus x minus 4 squared. I'm just going to leave it like that. Not square it out. You could square it out, but it's easy to just leave it like that. Take the square root of both sides. Y minus 2 is equal to plus or minus the square root of 9 minus x minus 4 squared. We want the top half of the semicircle, so we take the plus sign. So we're going to take the positive one. There we go, that's the top half. If it was a negative bottom half, we'd have taken the negative one. Now you just put the 2 over there. So y is equal to the square root of 9 minus x minus 4 squared plus 2. That's the semicircle. This is the line. And we want the distance between them, which is just the line, the top one minus the bottom one. Some people did the bottom one minus the top one, then we get the negative distance between them. Typically, distance you want is a positive number. To make it a positive number, you take the big one minus the small one, right? So we just take the line, this one, so the distance is the line 3/7 x plus 5 minus that thing, square root of 9 minus x minus 4 squared plus 2. Okay, so 5 minus 2 is 3, and then this is negative. So finally the distance is 3/7 x, 5 minus 2, so it'd be plus 3, minus the square root of 9 minus x minus 4 squared, and we're done. Okay, so that's the distance between them. It's going to be a positive number because the line is always bigger than that one. And of course, this only works up to 7. Okay, what's the distance between them over here? It doesn't make sense. Only works from x equals 1 to 7, like we said. All right, that is how you do that. Had to remember circles and semicircles, which is the top half. When you take the square root, you get plus or minus. If you want the top, you put the plus. If you want the bottom, you know, if I had drawn it this way, we would have taken the minus sign. Either one works. Okay, then I said, okay, well, I just made up this other line here. This line y equals 2x minus 5. Where does it intersect the semicircle? So it's going to go through here. It hits negative 5 here, slope of 2. It's going to hit the semicircle. So this is just an algebra problem. So you have to go 2x minus 5 equals the semicircle. And if you remember, if I remember, it was the square root of 9 minus x minus 4 squared plus, I gotta make sure I get this right because I just erased it, plus 3, no, plus 2, yeah, plus 2. Plus 2, that's the line. We want to know when the line is equal to the semicircle. Right, this is what we got in the had to get the previous one right, had to get the semicircle right to do this one. And now let's see, we put the 2 over here, that would make it subtract 2 from both sides, 2x minus 7 equals all this, 9 minus x minus 4 squared. Square both sides, over here we get 4x squared minus 2 times those multiply together, so that'd be 28, 28x, plus 49 equals 9 minus, now I'm going to square that out, 9 minus x squared, 2 times those multiply together is 8x plus 16. Okay, so I'm going to skip some steps here because I think you can do this. This is, you got to combine everything on both sides and put all the x's in the same side and everything. You're going to get a quadratic formula. I found when I did all that I got 5x squared minus 36x plus 56 when all that was done equals 0. Putting all these together and everything, that's what I got. And then you use a quadratic formula, and I got that x was 4.927. And when you know x, you can figure out what y is. Because y is 2x minus 5. So you plug that into y equals 2x minus 5. Or you could do the semicircle one, but this is a lot easier. And I got that the y value was 4.853. Okay, but the tricky part was, of course, you had to write the semicircle correctly. Line equals semicircle, square things, do all the algebra correctly, get all the x's right, and then use a quadratic formula. Now, the last part was easier. Now we want to know where the line hits the line for part C. So you had to figure out the line, of course, correctly for part A, which is a problem if you got that right. So we have our line here, 2x minus 5 equals, see if I remember it, 3/7 x plus 5. I think that was the line. And where did I put that? Yep, that's right. So this one's a lot easier, right? Let's put subtract the 3/7 x over here. So we have 2x minus 3/7 x, and put the plus 5 over here equals 10. I had to do some tricky algebra here. 2x is like 14/7 x, right? 14 divided by 7 is 2, that's right. Minus 3/7 x equals 10. That would be 11/7. 11/7 x equals 10. Or x is equal to, multiply both sides by 7/11 is 70 over 11. I think that's right. And then y then is going to be 2x, 2 times that minus 5. So 2 times 70 over 11 minus 5. 5 is 55 over 11. So that would be 140 elevenths minus 55 elevenths, which is 85 elevenths. So this is the y value. This is the x value. You can get decimals for it. If you get decimals for it, I think I got 6.36 and 7.73, which is fine. So 6.36 if you want to do decimals, and 7.73, I think. Okay, but clearly, yeah, this one, you had to get the line right from up above. Okay, so you just have to get those things correct for every problem here, or yeah, or it's, of course, it's all going to be wrong, which we don't want that. So really, really be careful with your algebra. Check things, double check things, make sure it makes sense, make sure your slopes make sense. So many people got to a 7/3 slope instead of 3/7, which, you know, you look at it and go, oh, that can't be right. Okay, moving on here. The next one. Number 4, we have this circle thing going on here. This is like the line hitting the circle one, right? I put all the points on here so you didn't have to worry about, you know, drawing the picture right, because that can get confusing and people get that wrong and everything's wrong. So you want to eliminate that. Find where the ball enters the green. We got to find the equation of the line and where it hits the circle. So first we write down, well, it doesn't matter which one you do first. Let's write down the equation of the circle. It's centered in the origin, which is really nice. So that's just x squared plus y squared equals the radius squared. The radius is 30. So the radius squared is 900. So 900. And now what about y? We have to have an equation for that line. And I made it nice, easy numbers. So let's see, we have 2 points. This point over here, I said the westernmost point, so we know it's right in the circle there. It's on 30. So it'd be x is 30, comma 0. So the slope would be 40 minus 0. 40 minus 0 divided by negative 50 minus 30, which is 40 over negative 80, which is negative 1/2. Clearly it's negative. It's not very steep. 1/2, yep, makes sense. Looks about right. So negative 1/2. And then we go y minus, let's choose this point, y minus 0 is equal to negative 1/2 x minus 30. That's always nice when that's 0. So the line is y equals negative 1/2 x minus minus is plus, and half of 30 is 15. So it hits at 15, which it looks like it does, right? There's 10. So yeah, it makes sense. Y-intercept is 15. Negative 1/2 x looks right. So we want to know where that line hits. Y equals negative 1/2 x plus 15. So we square this, plug it into here, and then do our math. So if we square this, we have y squared is equal to 1/4 x squared, right? 1/2 times 1/2 is 1/4. 2 times those multiplied together. The 2 gets rid of the 1/2. So it's just minus 15x. It's minus because this is negative. So 2 times, yeah, 2 gets rid of that. And then plus this one squared, which is 225. Plug that into here. So x squared plus 1/4 x squared minus 15x plus 225 equals 900. Now you write this as a quadratic formula. You put the 900 over here, you do all that stuff, and you get that x squared minus 12x minus 540 equals 0. It turns out you can use a quadratic formula, or you'll find that this actually factors, which is amazing. It's actually x minus 30 times x plus 18 equals 0. If it doesn't factor, you got to use a quadratic formula, which you could have used anyway. And you would have found that you'd gotten the same answers, whether you factored it or used a quadratic formula. This is easier if you can see that. So x then is negative 18, right? Negative 18, and the other x is 30. Now we knew this x is 30. We already knew that point. So we're trying to find this point. So negative 18 looks about right. And when x is negative 18, you can find y. Y is negative 1/2 x plus 15. Turns out y is 24. Which again, look at the picture. Yeah, 24 right about there. Yeah, looks about right. Always check that. Check, and you can clearly see about where it hits it. You could have guessed about that and knows the exact answers. Okay, so that's the first part. Now, let's erase all this. So we know where it hits the circle now. Negative 18, comma 24, 24, negative 18. And now the second part says, after she hits the ball, it travels at a constant speed 7 feet per second. For how many seconds is in the green? We got to find this distance. We need to find this distance, d, and then we can find the time, because the time is the distance divided by the velocity, and we know the velocity is 7 feet per second. So we just got to find that distance. So we know the distance formula. It's just a triangle, right? So a right triangle. So it's this squared plus that squared. The height is 24, and this is negative 18 all the way to 30, which is 48. Right? So negative 18 to 0, and then 30 more. Now you can also just go y minus 0 squared, 24 minus 0 squared, and then negative 18 minus 30 squared using the formula. Right? The formula for the distance is the square root of, it doesn't matter which one you do first. For some reason I wrote the y one first. Subtract the 2 y points squared, subtract the 2 x points squared. So we get the square root of 24 squared plus 48 squared. And I think it's like 13 point something. 53, sorry, this is the next one. That's 53.667 or something like that. And then the time is that number divided by 7, 53.667 divided by 7, which I got that was 7.67 seconds. Okay, take 7.67 seconds to get from here to here. All right, now the last part. Find the closest distance the ball gets to the cup at the center of the green. So we want to know the ball looks like how you're trying to hit it in the hole, right? You want to hit it right there, but you miss. So what is this distance here? What is this new distance? That distance d. Okay, and we know that's when this makes a right angle. So we know this line here, this perpendicular line, we got to find that perpendicular line. And we know the perpendicular line has a slope that's perpendicular to this line. We know this slope. This one's negative 1/2. So this new line is negative the inverse of that, right? The negative inverse of negative 1/2. So negative 1 over negative 1/2. 1 divided by half is 2. The negatives cancel. Slope is 2. So this line has a slope of 2, which it definitely looks like it has. It goes through the origin, so we know that it is simply y is equal to 2x. We want to know when y equals 2x hits our old line, and then we can figure out the distance between those 2 points. Well, our old line is right there, so when does y equal 2x hit negative 1/2 x? When does 2x equal negative 1/2 x plus 15? Right, when does our new line 2x equal our old line, which was negative 1/2 x plus 15? You put the x's, boy, that's just bad. Let me rewrite that. When does our new line equal negative 1/2 x plus 15? That's better. So you add the 1/2 x to here. We have 2.5, which is 5/2 x. 5/2 x equals 15. 5x equals 30. Or x equals 6. Wow, really? That's perfectly 6 there. So that's pretty cool. If x equals 6, the y value is just 2x. So y is equal to 2x, which is 12. So that point there is 6, 12. This point there is 6, 12. We want to know how far that is from the origin, what that distance is. So real easy, use the distance formula again. And since it's 0 there, it's 6 minus 0 squared plus 12 minus 0 squared. So that's real easy. You just don't have to worry about the y value. So 6 squared plus 12 squared. And I believe you plug that into your calculator. You get that's about 13.42. So it was about 13.42 feet from the hole, from where you wanted to hit it. So close. Oh well. Okay, so When you want to find the closest distance, you find the perpendicular line. You usually know one line. The slope is perpendicular, negative inverse, goes to the origin, so it makes that line formula really easy. Just y equals 2x, you set them equal, find that point, and then you can find the distance between the points to find that distance. That's the trick there. Okay, that's number 4. I think we have one more left. We can do it. Last one, number 5 here. Let's see here what's happening. Okay, we did all this stuff. Okay, so Maddie's walking around. She goes, okay, we know this point to that point. So parametric equations are always the starting point plus the velocity in that direction times time, y starting point plus the y velocity times time. She goes 2 feet per second. So first we got to figure out how long it takes her. Okay, then we can figure out the velocity. So that's the first step. We got to figure out how long it takes her. So to do that, we got to find the time it takes her is the distance divided by the velocity. She's going 2 feet per second, and the distance is, we got to use the distance formula. How far is it from this point to that point? So the distance is the square root of, so let's do the x's first, subtract the x's, 5 minus negative 3 squared. 5 minus negative 3 squared, they're 8 apart, right? Plus, how far are the y values apart? They're clearly 6 apart, 8 minus 2. So 8 minus 2 squared, that's the distance. So that's 8 squared plus 6 squared. And I believe, I think that actually worked out really nice. It ends up being 100. So that's a square root of 100, right? 8 squared 64 plus 36, yeah, which is clearly 10. She goes 2 feet per second. So the time, the distance she goes is 10 divided by 2, so it's 5 seconds. So it takes her 5 seconds to do that. So, in 5 seconds, her Vx, she goes in the x direction from negative 3 to 5, which is 8. So she goes 8 in 5 seconds. So 8/5, which you can leave it as 8/5, or that's 1 3/5. That's also 1.6 if you like. That's her x velocity. And the y direction, she goes from 8 to 2, so she goes 6 in 5 seconds, which is 1 1/5, which is 1.2. Now, here's where you got to be careful. She's going from negative 3 to 5 in the x direction. She's going this way. But she goes from 8 to 2, so then she goes downwards in the y direction. So clearly it's a negative y velocity. A lot of people are getting the negatives wrong. Now we can plug in these numbers. Her x0 starting point was negative 3. It's always from the starting point. So her x equation is negative 3. That's the x0. Plus Vx 1.6t. Right? Vx is 1.6. And the y direction starting point was 8. And then it's minus, because she's going the negative direction, so minus 1.2t. A lot of people got those things wrong. Yeah, got confused with negatives and everything. So these are our parametric equations. We want to know wherever she is. We always know her x position is negative 3 plus plug in the time. Y position is 8 minus 1.2 plug in the time. Okay, we are almost done. We can do this. Now the next part of it's, if she continues walking past the point 5,2, how many additional seconds will it take her to reach the x-axis? The x-axis is where y equals 0, right? Y equals 0 on the x-axis. So we want to set this equal to 0. We need our y equation. We set that equal to 0. So that's not so bad. So we want to know when is y 0. So 8 minus 1.2t is equal to 0. Put this over here. 8 is equal to 1.2t. Divide both sides by 1.2. So t is equal to 8 divided by 1.2. And I believe that's 6.67. It's 6.67 seconds. So took her 6.67 seconds there. So how many additional seconds? Took her 5 seconds to get to that point. So it's just 6.67 minus 5, so 1.67 additional seconds. Took her 5 seconds to get to that point. and then an additional 1.67 seconds to hit the x-axis because it took her 6.67 seconds the whole time. So again, the trick there was when is y 0 and how many seconds more is that than it took her to get there, which we already figured out was 5 seconds. Phew, okay, that was it. Lots of places to go wrong. You have to be really, really careful with your algebra. So many people made silly mistakes, especially in the beginning, and then the whole thing is wrong. So really check your work and make sure it makes sense. Like look at the picture. I didn't draw a picture here, but you should have. Or at least do something like this just to make sure, oh, it's negative velocity. We're going downwards. Vy is negative. If you got that wrong, you're going to get the second part wrong. And that's just the way it works. You got to be really, really careful. Make sure your answers make sense. I know there's time pressure, you know, when you're trying to work fast and getting panicked and stuff. So yeah, it's hard. But anyway, hope this makes sense. And then you can try again and hopefully get things more correct on a retake. Awesome. Thank you for listening, as always.